Okay, so as I told today, we will be looking into some prerequisite of this particular course. Okay, prerequisite of ECE3001 linear integrated circuit. So today we will be discussing about Kirchhoff's laws, that is Kirchhoff's current law, Kirchhoff's voltage law, then one technique which is known as node analysis. So that is what I have planned for today. So first thing that I would like to discuss with you is Ohm's law. So do you remember what is Ohm's law? Anybody? You might have studied in your first semester. What is Ohm's law? Anyone? Nobody?
Equal to IA.
Hmm? Tell me.
Voltage equal to current into resistance.
Voltage equal to current into resistance. That is correct. So the definition, the theorem states like this: the current flowing through a resistor is directly proportional to the potential difference across a resistor, or vice versa. I can write V is proportional to I, or I is proportional to V. So V is equal to I into R, where V is the potential difference or voltage developed across the resistor, across the resistor. And then I is the current flowing through the resistor, and R is the resistance of the resistor. So please remember, voltage developed across a resistor R is equal to current multiplied by the resistance of the resistor. Okay, so V equal to I into R. So this is the electrical symbol of a resistor. Okay. So in maybe in European Union and all, they will be using a box, okay, a rectangular box. But here in India, we will be using this symbol, electrical symbol like this. Okay. So suppose this resistor is having a resistance R and then a current. Okay, you can see this arrow. So this is the current flowing through the resistor I. Then a voltage will be developed across the resistor. That will be V. So here, please note that the voltage will have a polarity. Okay, voltage will have a polarity, plus and minus. So positive will be developed where the current is entering the resistor. So always remember that. Okay, so if the current is flowing from left to right, voltage developed across the resistor will be such that positive of the voltage will be to the left side and negative to the right side. If the current was entering from here, then positive of the voltage will be here and negative will be here. Okay. So always remember this convention. Okay. So voltage developed across a resistor will be V is equal to current times the resistance R. Okay. And the positive sign of the voltage developed will be at the point where the current is entering the resistor. So please remember this. Now, next law which we require is the Kirchhoff's voltage law. Can anyone tell me what is Kirchhoff's voltage law? Kirchhoff's voltage law. Anybody? Anyone? What is Kirchhoff's voltage law? I think you have studied in your first semester. Anyone? Okay, Kirchhoff's voltage law states that the algebraic sum of the voltages around a closed loop is always zero. Okay. Algebraic sum of all the voltages around a closed loop is always zero. Okay, so this is a closed loop. Okay, there is it is not open. Correct. That is why it is called a closed loop. So there are 1, 2, 3, 4, 5 elements here. Okay, 1, 2, 3, 4, 5 elements here. We don't know what that element is. Okay, and now there are voltages developed across this somehow like this. We don't know how it is. We don't know whether it is a resistor or anything. Some component is there, and the voltage developed across these elements are like this. Okay, so can you tell me how will you write the KVL of this particular equation? For example, voltage across this element is VE, voltage across this element is VA, voltage across this element is VB, voltage across this element is VC, voltage across this element is VD. This is what is given. So if you want to write KVL, please remember this always. If you want to write Kirchhoff's voltage law, you can start at any point. I can start from here. 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 Okay, anywhere. Suppose I'm starting from here and you can go in any direction you want. Suppose I want to go in this direction, you can go. Or you want to go in this direction, you can go. So I'm going to go in the clockwise direction. Okay. So first, what is the first thing that comes when I travel like this? What is the first thing that comes? What is the first voltage that comes? What is this voltage? I'm starting from here. So the first voltage that comes is what? Minus VE. Is it clear? Starting from here, the first voltage that is coming is minus VE. Then I'm going like this. What is the next thing that comes?
Plus VA.
Plus VA. Then
Minus VB.
minus VB. Then
Minus VC.
minus VC. Then
Minus VD.
minus VD. Okay, I reached back here at the point. So the KVL can be written like this. Okay, minus, so starting from here, it will be minus VE plus VA minus VB minus VC minus VD equal to 0. Clear? So that is how you can write the Kirchhoff's voltage law. Okay. Now the next law is our Kirchhoff's current law. Okay. Anyone remember? This is a very easy law. I think majority of you might be remembering. Kirchhoff's current law. What is it? Anybody remember? Kirchhoff's current law. Okay, Kirchhoff's current laws.
The sum of
Ah,
going out current is equal to the sum of incoming current.
correct, correct. You stated the second one. The sum of currents entering a point or a node is equal to the sum of the currents leaving a node. Okay. So, or you can write algebraic sum of the currents flowing into different branches, meeting at a node in a circuit is always 0. Or indirectly, what you told is correct. That is the sum of the currents entering a node or a point is equal to the sum of the currents leaving the node. So, for example, this one. Can you quickly tell me what is the KCL equation of this? Identify which are the currents entering, add it. Identify which are the currents leaving, add it, and then equate both.
I1 plus I4 equal to I2 plus I3 plus I5.
Correct. So here I1 or I2 plus I3 plus I5 is equal to I1 plus I4. You can see that I2, I3 and I5 are entering the node or the point, and I1 and I4 are leaving the point. So I will add the currents which are entering the point, that is I2, I3 and I5 will be equal to, I will add the currents which are leaving the point, that is I1 and I4. So this is a very important law for our particular course. Okay, so you have to be you have to understand this particular law. Okay, always remember the currents entering a particular point will be equal to the sum of the currents leaving that particular point. Okay, now this is the important analysis that is required for learning this particular course, which is known as the node analysis. There is another analysis which is called mesh analysis, which I don't need for this particular course. So that is why I am going to concentrate for today. We will be discussing about node analysis. Then only we can start our course. Okay. So node analysis, before going to node analysis, I will tell you what is a node. Do you know what is a node in an electrical circuit? Node means what? A node is a point, correct? But Can you elaborate on it? In an electrical circuit. Okay, I'll tell you. Node is a point in an electrical circuit where two or more elements are connected together. So remember, two or more elements. Okay, so if at a point two or more elements are connected together, then it is called a node. Now there is another concept called principal node. Can you tell me what will it be? From the first statement, can you tell me what will be a principal node? Node is a point where two or more elements are connected together. So what will be a principal node?
Only one element.
No. More than two. Okay. Principal node is a point where more than two elements are connected together. Is it clear? Which means that all principal nodes will be nodes, but all nodes need not be principal nodes. Okay. So please remember, node is a point where two or more elements are connected together, and principal node is a point where more than two elements are connected together. I will give an example of this particular. So you can see a particular circuit. You can see a very particular circuit here. So can you count and tell me how many nodes are there? Just take some time and identify how many number of nodes are there. Please remember, node means a point where more than two elements are connected. So please remember, this is a resistor. So this is an element. What is this thing? What is this symbol?
Resistors.
This one. This is a resistor, R3. This is a resistor. What is this thing? Looking into the name, can you tell? V3. What will this
Battery
be?
volt.
Battery voltage source. Okay, battery. Particularly, it is a battery. So this is a battery. This is a battery. This is a battery or a voltage source. And what is this?
Current.
I means what?
Current.
Current. So it is a current source. Okay. So this is a current source. So tell me how many nodes are there? So the different elements
Five.
are five. Once more, you check. Only five. Node is a point where two or more elements are connected together.
Seven, sir. Seven.
Not seven, six only other. Okay, I will mark it. Okay. So this one is a node. Is it clear? This point is a node, right? Element R3, R1, and V1 are connected. So this is a node, and this is a node, right? So this also I am marking. Okay, V2 I am marking, and now this one is also a node, correct? This point is also a node. Now, can you tell me which are the remaining nodes? At this point, you can see V3 is connected, this voltage source is connected, this resistor is connected, this resistor is connected, and this current source is connected. At this point, this resistor, and this resistor is connected. Similarly, this point, correct? This point, what all things are connected at this point? This voltage source is connected, this voltage source is connected, this resistor is connected, this current source is connected. So this entire line, okay, this entire line is one node. Now, which are the remaining nodes? Can you tell me? Two more nodes are there. Can you tell me? Two more nodes. Which are those? You can tell between
R5.
Between
R5.
no, that point is same only, na. You are telling this point, right? That is same as this point, right? Nothing is in between, correct? Which means this point is same as this point. Understood? Correct? Is there anything in between here? No. Which means this point is same as this point. This point is same as this point. This point is same as this. So this entire line is same. So here I have this one is a node. That is because R3 and V3 are connected together here. So this is a node. Can you identify one more node is there? Which is that? One
R2
more.
and V2.
Correct. R2 and V2. The point between R2 and V2. So here you can see it at this V5 node, R3 and V3 are connected together. At this point, R2 and V2 are connected together. So the nodes are 6, V1, V2, V3, V4, V5, V6. Now out of this, how many principal nodes are there? Can you tell me which are not principal nodes here? Or which are the principal nodes?
V2.
V2 is a principal node, correct? Because 3 elements are connected. Now, which is another principal node?
V3.
V3 is also a principal node because how many elements are connected there? At this point, how many elements are connected?
3.
Not 3, right? 1, 2, 3, 4.
4.
So it is a principal node. Now V1, is it a principal node?
No, sir.
How many elements are connected at this point?
3.
3. So it is it a principal node or not?
It is. It is.
It is a principal node. Now V5, is it a principal node? How many elements are connected here?
2.
2. So is it a principal node?
No, sir.
No. So V5 is not a principal node. Is V6 a principal node?
No, sir.
No, because only 2 elements are connected. So the principals nodes are only V1, V2, V3 and V4. Is it clear?
Yes, sir.
Okay. So now we will look into one small problem. Okay. Very small problem. Okay. Don't get panicked by seeing the circuit and all. Okay. We will try to do it. So question is write the node equations of the circuit and hence find the current flowing through each resistor. Okay. So step 1 is identify the principal nodes. So can you tell me how many principal nodes are here? So take some time and identify how many principal nodes are there. I want principal nodes. How many principal nodes are there?
Two, sir.
Not two, right? Is this a principal node where I am moving the mouse? This node, is it a principal node or not?
It is.
Yes, it is. This one? Is this a principal node?
Yes.
Yes. Now one more is there. What is that? This line to hold together, correct? Because here this current source, this resistor, and this current source is connected together, correct? So there are three principal nodes and make one reference node. So these are the nodes. So this is one node. Okay. So node I will be marking with one voltage V1. Then second node I am marking with V3. And the third node I am marking with V3. Clear? So there are three principal nodes. Is it clear? Any doubt in this?
No, sir.
Okay. So now what we will do is we will make one node as a reference node. Reference node means voltage we will assume as 0. Okay, or the ground. So reference node I am taking it as V3. If you want, you can take V1, V2. Okay, no issues. But usually whatever what is that ground one is there, we will take as a reference node. So this voltage I am taking as 0. That is the first step. Okay. Now what you have to do is mark the current flowing through different branches. So here you can see this is a current source, correct? So you in this branch current will be 4 ampere. Now through this resistor I will mark one current. Through this resistor I will mark one current. Through this resistor also I will mark one current. You can mark in any direction you want. I am marking like this. So this current I am marking as I1. Is it clear? Through this resistor, I am marking down. It is your wish. Okay, you can change the direction you want. So I am marking it as I1. Through 12 ohm, I am marking like this, I2. Through the 6 ohm, through the right 6 ohm, I am marking as I3. Is this much clear? Please note that you can mark in any direction. If you want, you can mark I2 from right to left. No issues. No need to mark from left to right. No problem. Whatever direction you want, you can mark. Is it clear up to this? Any doubts?
No, sir.
Okay. So once you have marked the directions of the current through each branch, what you have to do is, so this is the circuit with all the current and all marked. Now what will I do is, I will write the expression for current flowing through whatever currents we have marked. So what is the expression for I1 is what I am going to check. Okay. Now I1 direction I have taken down, correct? You know that current will flow from higher potential to lower potential, correct? Current has a property that it will flow from higher voltage to lower voltage. Okay. So if I am marking current I1 like this down, it means that this potential at this point is more than the potential at this point. Is it clear? Is it clear? If I am marking current I1 down, it means that voltage at this point is greater than the voltage at this point is what my assumption is. Clear. Similarly, I2 I have marked in this direction. So voltage at this point is V1 and voltage at this point is V2. So if I am marking current I2 in this direction, what is my assumption? Whether V1 is more or V2 is more?
V1.
V1 is more. Correct. So now I am going to write an expression for I1. Okay. So I1 means current flowing through this resistor, this 6 ohm resistor. Now current flowing through any resistor can be found using Ohm's law. What is Ohm's law? V equal to IR. Correct. Voltage across the resistor is equal to current into the resistor. So from that expression, what is the equation for I? V equal to IR means I equal to what?
V by R.
V by R, which means that current flowing through a resistor is equal to voltage across the resistor divided by the resistor. Correct. Now I1 I have marked in this direction, which means that as I am assuming that voltage at this point is more than voltage at this point. Then what is the voltage difference between this resistor across the resistor? Voltage here is V1. What is the voltage here? At this point, what is the voltage? At this end, it is V1. What is the voltage at this point? Voltage at this point is V1. So what is the voltage at this point? It is, what is that?
V1, sir.
V3.
V3, correct. Because here it is V1, here it is V3. So what will be the voltage difference across the resistor? What will be the voltage difference across the resistor? Here it is V1 and here it is V3. So what is the difference?
V1 minus V3.
V1 minus V3, correct. So what will be the current? V1 minus V3 divided by 6. Is that clear? I1 can
Yes,
be
sir.
written
Yes,
as
sir.
V1 minus V3 divided by 6. But what is V3? V3 is our reference node and value is 0. So what is I1? V1 by 6. Is it clear?
Yes, sir.
Okay.
sir.
Now can you tell me what is the equation for I2?
V2 by 12.
No. Look where
V1 minus V2 by 12.
V1 minus V2 by 12. You got the idea? I2 is the current flowing through this resistor in this direction, which means that voltage difference will be V1 minus V2 divided by the resistance. You will get V1 current, V1 minus V2 by 12. Similarly, can you tell me what is the equation for I3?
V2 by 6.
Correct, V2 by 6. Or actually V2 minus V3 by 6. Since V3 is 0, V2 by 6. Is it clear? Any doubt in this? Okay. Shall I proceed?
Yes, sir.
Okay. So once we have written the current, now what you have to do is I will apply KCL. Okay. I will apply KCL at the node at this point and this point other than reference node. So if I apply KCL at the node V1, can you tell me what is the KCL at node V1? Which is the current entering point V1? Which is the current entering point V1?
4 amps.
4 ampere. Which are the currents leaving the point V1?
I2 and I1.
I1.
Correct. I2 and I1. So what is the KCL equation?
For A equal to I2 plus I1.
4 is equal to I1 plus I2 or I1 plus I2 equal to 4, whatever way you want. But what is I1? We already got the equation of I1.
V1 by R.
V1 by which R?
6.
V1 by 6. Correct. What is I2?
V1 minus V2 by 12.
V1 minus V2 by 12. So I am substituting that. You understood? 4 is equal to V1 by 6 plus V1 minus V2 by 12. Now I will take the LCM and I will get one equation. Clear? Okay, so this is what is known as the first node equation. Is it clear? Taking the LCM and all, I will get like this. Similarly, can you write down what is the node 2 equation? I will give you 2 minutes. Please do. First, you write down the KCL equation, then substitute for the currents, and finally get an equation like this. What is the KCL equation?
I2 equal to I3.
Only I3.
Plus 2A.
Correct. I2 equal to I3 plus 2. A is the unit of current, okay, ampere. Okay, so I2 equal to I3 plus 2. So whatever you told is correct. So I'm writing that here. Now substitute. What is I2?
V1 minus V2 by
12. Correct. What is I3?
V2 by 6.
Correct. So V1 minus V2 by 12 equal to V2 by 6 plus 2. I will take the LCM. Okay. I'll get the equation like this. So now we got two equations. Now you can use your calculator and solve it. Okay. So that and all I hope you know, correct. Use calculator and solve. You will get V1 equal to 15 volt, V2 equal to minus 3 volt. Understood. That is what we are getting. Okay. Now, once you know V1 and V2, you can find the current flowing through each resistor. So first we got V1 equal to 15 and V2 equal to minus 3. So how will you find what is I1? I1 is the current flowing through this 6 ampere. So what is the equation for I1? What was the equation
15
for 15
by
by
6.
6? Correct. 15 by 6. That is 2.5 amperes. What is a I2? What will be I2? Can you quickly calculate? What will be I2? Equation for I2 is, what is the equation for I2?
18 by 12.
18 by
3 by 2.
12. Correct. 18 by 12. 3 by 2, that is 1.5 ampere. Correct. What is I3?
Minus 1 by 2.
Minus
Minus
0.5.
minus 1.5. Negative value, if you are getting, it means that current is flowing in the other direction. Understood? Whatever direction you have taken here is not the current direction, correct direction. It will be up. That is all. You understood? If you are getting negative answer means it is not wrong. Okay. It just means that the direction of current is reverse. Okay. So I won't, we will try to simulate this in multi-sim and check whether we are getting the same answer. That is what I want to do. And another example I have given here so that you can go through it after this class. Okay. So let us go to NI multi-sim. I hope you guys have created the account. Okay. I'm going to NI multi-sim. Just if you are, so nimultisim.com, then log in. You guys can also try it out because the assignments I will be giving based on this. Okay. Okay. I'm logging in. Once after you log in, we will. Have you logged in?
Just a minute, sir.
Okay. Once you have opened this, you let me know. In mobile itself, you can open, no problem. Or laptop, if you have, you can open in laptop also. Okay. So once you get this page, okay, those who have not opened it is, please do this video. You have to click on create circuit. Okay. So that one page will open. Okay. click on create circuit so that one page will open. This is where you can wire your particular circuit. Okay, so left side you can see all the sources, all the different components which are there. So what all things are required, you just take. Okay, so looking into this, I need resistors, I need two current sources. So what I will do is, first I will go to here, you can see sources. Inside source you can see DC current source. Okay, so click on that and just place it here. Okay, so this is our first current source. Now what is the value of the current source that is required? 4 ampere. So what you can do is click on this 1 ampere. By default it will be 1 ampere. Change it to 4. Okay, now another current source is required. So again I will go to source, click on this current source, and I will place it here. But here you can see that the arrow is down, correct? So what I will do is, I will just, here you can see rotate. If you click on this, you can see rotate. So rotate it so that it will become down. Now what is the value of this current source? It is 2 ampere. So I will change this to 1 ampere. I will click on that and change it to 2. Okay, please refer the video if you are not able to do it with me. Okay, now I need 3 resistors. So again, resistors, I will go left panel, you can see the resistor symbol. So click on that. There you can see resistor, capacitor, inductor and all. So I need a resistor. So click on R. Okay, I need resistor to rotate. So I'll rotate like this and I got. Clear? Now what is the value of the resistor required? 6 ohm. So click on this value and change it to 6 ohm. Now another resistor I will take. Again I will go here, take the resistor, I'll place it here. The value of this particular resistor is 12 ohm. So I'll click here, change it to 12. Again I will go here, take one more resistor, I will place it here, I will rotate it so that it becomes as per the circuit. Okay, and value required is 6 ohm. I will click on this, change it to 6 ohm. Okay, now all circuits require a ground. So I will go here, take the ground and connect it down. That is our reference node. Okay, now you just have to connect. Okay, the one spool will come when you go near to it. Connect, that's it. Okay, I will connect. From here I will connect. Okay, all these things you just have to drag your mouse and connect. So it is very easy. Please try it today itself. Night, you can, if you are not getting, you can message me in WhatsApp. I am already in the group. Okay, so please try to complete this. Okay, so I have connected the circuit, complete circuit. Now what you have to do is, I want to measure the voltage and current. So here you go to analysis and annotation, you can see voltage probe. Click on that and place it here. Okay, if you want to change the name, you can change. I want to change it to V1. I am changing it. Similarly, another voltage probe, I will place it here so that I will get V2. Okay, now current also, if I want to measure, I will take this. This one is my current. Okay, I will place it on the branch. So this is I1. Next current, this is I2. Okay, I will change the name to I2. Okay, now another one more current source, current probe, change it to I3 so that I can measure. I'm just giving the name, that's all. Okay, I'll move this little this side so that everything can be visible. Now just run this and you will see that it is same as what we got. Correct? See here, V1 we got 15 volt, correct? V1 15 volt, V2 minus 3 volt, I1 we got 2.5 ampere, that is correct. I2 we got 1.5 ampere, that is correct. I3 we got minus 5 ampere, which is minus 500 milliampere, which is same. Okay, so this is how you can simulate anything. Okay, I will save this and share the link to you. Okay. Node analysis circuit 1. Okay, I am saving it. I will share you this link so that you can experiment with the second one. Okay, so please, second circuit I have given, you can connect that and check whether the answer that we have got there is correct or not. Okay, I will be okay.
Sir, how to change kilo ohms to ohms?
What you can do is just go there. K will be there automatically. You delete that, change. That's it. Understood? Suppose you have a resistor. Okay, I'm taking a resistor 1K. Okay, click on this. 1K it will be.
Okay,
there.
sir. Okay, sir.
You replace with 8, whatever you want. Understood?
Okay, sir.
Very simple thing. You can see whatever value we have got is correct. That is. Anyway, I have shared the link. Please go through it. What I want you guys to do is go through the second problem that is given. Okay. You can try to do by yourself also. No issues. Huh? And then check, wire this circuit and check whether you are getting the answer. So here voltage, if you want voltage source, you can go here. This is the voltage source. Okay. So this is positive and this is negative. If you want to rotate, you can rotate. Any doubts if you have, you can contact me in WhatsApp, no issues. Night I will be available. Idea? Any doubts in this? I will upload the slides. Any doubts? Please tell me if you have any doubts.
No, sir.
Yeah. Any doubts? Anybody got this? No, right? Because I was a little fast.